All right, let's take a look at number 2. For each measuring device shown below, A, B, and C, identify the quantity, measured and tell when it would remain constant and when it would vary. All right, so let's start with A. This is a spring scale. The term spring scale should sound familiar because it was in your notes, okay? In your notes, we identify that spring scales measure weight. Now, weight can vary, okay? Because notice we have the spring scale, we have the same amount of gravel or whatever this is, beans, I don't care. The same amount of stuff here. The amount of stuff is not going to change. However, if we take this sample and this spring scale and we move it to the moon, the weight is going to be much less. If we take it to Jupiter, it's going to be much more. And so, we can say that weight varies with gravity. B, this is a balance. Balances measure mass. Now, a lot of people think that mass and weight are the same thing, or at least they can't tell the difference between the two. They also think that scales and balances are the same thing, and they are not. Because notice, in A, the spring scale is not comparing this amount of stuff to anything else. It's just allowing gravity to accelerate it downwards. But in this balance, we are doing just that. We're balancing. Okay, we're balancing this sample versus a known standard. Okay, this is a weight. We already know what this is. It's already been defined as something, and so we're comparing whatever this stuff is to our standard. Now, to that point, mass will not vary. The amount of stuff in a substance is not going to vary even if we increase or decrease gravity. Because notice, if we increase gravity on this sample, we're also going to have to be increasing gravity on this sample, but on the standard, by the exact same amount. So there will be no overall movement of this needle. Okay? Mass does not vary. Especially due to gravity. That's kind of one of the things that our book is trying to emphasize. Now, C is probably something that you don't actually know off the top of your head. This is called a volumetric flask. Okay? It's not a graduated cylinder because it has this bulb down here at the bottom. And one clue that this is volume is this 250 milliliters, right? 250 milliliters is printed on the flask, and it's milliliters. Milliliters is a measurement of volume. Now, if you want to know when or how this volume can vary, I'll ask a very simple question. If you were to have a balloon and you were to heat up the air in that balloon, what would happen to the balloon? You would say it expands. What were to happen to that same balloon if you were to take it and put it into your freezer? It would contract. And so it varies with temperature. And it's as simple as that.